Hey everyone, welcome back. Up till now, we've learned a lot of interesting and complex techniques on how to use Git locally. We started with the very basic Git workflow for modifying files, staging the changes, and then committing them. We then looked at other things we can do with Git, like deleting or renaming files, getting more information about commits, or skipping the staging area altogether. Next, we saw how to undo staged, unstaged, or committed changes in our Git repositories. Finally, we learned a bit about how to work with different branches, like how to merge changes from separate branches. Now, we'll learn a load of new things related to GitHub and remote repositories. We'll first talk about what GitHub is and why it matters, and then we'll dive into how to work with GitHub and other remote repositories. Being able to use remote repositories allows us to effectively collaborate with others. Earlier this videos, we called out that Git is a distributed version control system. Distributed means that each developer has a copy of the whole repository on their local machine. Each copy is a peer of the others. But we can host one of these copies on a server and then use it as a remote repository for the other copies. This lets us synchronize work between copies through this server. Any of us can create a Git server like this one, and many companies have similar internal services. We will use an online service. We will use GitHub. GitHub is a web-based Git repository hosting service. On top of the version control functionality of Git, GitHub includes extra features like bug tracking, wikis, and task management. GitHub lets us share and access repositories on the web and copy or clone them to our local computer so we can work on them. To use GitHub, the first thing you need to do is create an account if you don't have one already. Signing up online is free and relatively simple. Once you've done that, you can either create your own repos or contribute to repos from other projects. If you don't have a GitHub account yet, now is a good time to create one. Visit github.com to sign up for their service. Let's do this now. Going step by step, we'll start by clicking the Create a Repository link on the left. This will take us to the repo creation wizard. The wizard is pretty straightforward. The first thing we need to do is give a name for our repo. We'll call this repo Health Checks. After that comes a description of what the repo will be used for. We'll say that it'll be used for scripts that check the health of our computers. Then we need to select whether we want the repo to be public or private. We'll go with private for now. Finally, the wizard can help us get started with some few initialization files like a README, a gitignore, or a license file. We'll go with just the README for now, and then create the repo. Using the wizard, we created the repo and have a fresh remote repository ready to go. Let's get to work. First step is to create a local copy of the repository. We'll do that by using the git clone command followed by the URL of the repo. GitHub conveniently lets us copy the URL from our repo from the interface so that we don't have to type it. We're now ready to clone the repo into our computer. We'll do that by calling git clone and pasting the URL we copied. Just like that, we've downloaded a copy of the remote repository from GitHub onto the local machine. This means that we can perform all the Git actions that we've learned up till now. Since the repo is called Health Checks, a directory with that name was automatically created for us and now has the working tree of the repository in it. So let's change that directory and look at the contents. Our repo is basically empty. It only has the README file that GitHub created for us. This file is in a special format called Markdown. Let's add a bit more content to it. We've changed this file. What do we need to do now? We need to stage the change and commit it. We've seen a couple of different ways to do that. Let's use our shortcuts to do this in just one command. Okay, we've modified our README file, but we've seen all this before. We got to a remote repository set up on GitHub, so let's use it. We can send our changes to that remote repository by using the git push command, which will gather all the snapshots we've taken and send them to the remote repository. In this case, we've only taken one snapshot. We'll talk more about what's going on behind the scenes with git push and remote repositories later. But the mechanics are pretty simple. To push our modified README up to GitHub, we'll just call git push. After that, we see a bunch of messages from Git related to the push. When we access our project, we see the contents of the README file. So if we check our repository on GitHub, we should see the updated message. Pretty cool, right? We've taken the local changes on our computer and pushed them out to a remote repository hosted on GitHub. Now, let's use a credential helper which caches our credentials for a time window so that we don't need to enter our password. Git already comes with a credential helper baked in. We just need to enable it. We do that by calling git config -- global credential.helper cache. We can try another git command. Git pull, which is the command we use to retrieve new changes from the repository. With that, we've seen how to create repositories on GitHub, clone our remote repository, push changes to it, and pull changes from it. To understand remote repositories and Git's distributed nature a bit better, imagine you're working together with some friends to design a computer game. Each of you has a different portion of the game you're responsible for. One person is designing the levels, another the characters, while others are writing the code for the graphics, physics, and gameplay. All these areas will have to come together into a single place for the final product. Although your friends might work on their parts by themselves from time to time, everyone needs to send out progress updates to let each other know what they've been working on. You will then need to combine their work into your own portion of the project to make sure it's all compatible. Using Git to manage a project helps us collaborate successfully. Everyone will develop their piece of the project independently in their own local repositories, maybe even using separate branches. Alongside the local development branches like master, Git keeps copies of the commits that have been submitted to the remote repository in separate branches. If someone has updated a repository since the last time you synchronized your local copy, Git will tell you that it's time to do an update. If you have your own local changes when you pull down the code from the remote repo, you might need to fix merge conflicts before you can push your own changes. In this way, Git lets multiple people work on the same project at the same time. When pulling new code, it will merge the changes automatically if possible, or will tell us to manually perform the integrating if there are conflicts. So when working with remotes, the workflow for making changes has some extra steps. We'll still modify, stage, and commit our local changes. After committing, we'll fetch any new changes from the remote repo, manually merge if necessary, and only then we'll push our changes to the remote repo. When we call a git clone to get a local copy of a remote repository, Git sets up that remote repository with the default origin name. We can look at the configuration for that remote by running git remote-v in the directory of the repo. Here we see the URLs associated with the origin remote. There are two URLs. One will be used to fetch data from the remote repository, and the other one to push data to that remote repo. If we want to get even more information about our remote, we can call git remote show origin. There's a ton of information here, and we don't need all of it right now. We can see the fetch and push URLs that we saw before, and the local and remote branches too. For now, we only have a main branch that exists locally and remotely. So the information here seems a bit repetitive. Once you start having more branches, especially different branches in the local and remote repo, this information starts becoming more complex. Whenever we're operating with remotes, Git uses remote branches to keep copies of the data that's stored in the remote repository. We could have a look at the remote branches that our Git repo is currently tracking by running git branch -r. These branches are read-only. We can look at the commit history like we would with local branches, but we can't make any changes to them directly. To modify their contents, we'll have to go through the workflow we called out before. First, we pull any new changes to our local branch, then merge them with our changes and push our changes to the repo. We can also use git status to check the status of our changes in remote branches as well. Now that we're working with a remote repository, git status gives us additional information. It tells us that our branch is up to date with the origin/main branch, which means that the main branch in the remote repository called origin has the same commits as our local main branch. But what if it wasn't up to date? So first, let's look at the output of the git remote show origin command. Check out how it says that the local branches are out of date. This happens when there were commits done to the repo that aren't yet reflected locally. Git doesn't keep remote and local branches in sync automatically. It waits until we execute commands to move data around when we're ready. To sync the data, we use the git fetch command. This command copies the commits done in the remote repository to the remote branches, so we can see what other people have committed. Let's call it now and see what happens. Fetch content is downloaded to the remote branches on our repository, so it's not automatically mirrored to our local branches. We can run git checkout on these branches to see the working tree, and we can run git log to see the commit history. Let's look at the current commits in the remote repo by running git log origin/main. Looking at this output, we can see that the remote origin/branch is pointing to the latest commit, while the local main branch is pointing to the previous commit we made earlier on. Let's see what happens if we run git status now. Git status helpfully tells us that there's a commit that we don't have in our branch. It does this by letting us know our branches behind their remote origin/main branch. If we want to integrate the branches into our master branch, we can perform a merge operation, which merges the origin/main branch into our local main branch. To do that, we'll call git merge origin/main. Great. We've merged the changes of the main branch of the remote repository into our local branch. See how Git tells us that the code was integrated using fast forward? It also shows that two files were added, check free space and freememory.py. If we look at the log output on our branch now, we should see the new commit. We see that now our main branch is up to date with the remote origin/main branch. With that, we've updated our branch to the latest changes. We can use git fetch like this to review the changes that happen in the remote repository. If we're happy with them, we can use git merge to integrate them into the local branch. Since fetching and merging are so common, Git gives us the git pull command that does both for us. Running git pull will fetch the remote copy of the current branch and automatically try to merge it into the current local branch. Let's see if there have been any new changes made to the repository. We'll run git pull and see what changes we get. If you look closely at this output, you'll see that it includes the output of the fetch and merge commands that we saw earlier. First, git fetched the updated contents from the remote repository, and then it did a fast-forward merge to the local main branch. We'll see that the check free space file was updated as well. We can look at the changes by using git log -p-1. We see that an empty function called check disk full was added to the check free space file. What if we found a new branch when we call git pull command? Let's try this out. We see that there is a new remote branch called experimental. Your friend told you that they've started working on a new feature in that branch. Let's check out the output of git remote show origin and see what it says about that new branch. We see that there's a new remote branch called experimental, which we don't have a local branch for yet. To create a local branch for it, we can run git checkout experimental. When we checked out the experimental branch, Git automatically copied the contents of the remote branch into the local branch. The working tree has been updated to the contents of the experimental branch. Now we're all set to work on the experimental feature together with our colleague. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, We'll look at what happens when we try to push changes, especially when our changes generate conflicts. Thanks for watching, and see you soon.